So guys, finally we reached to the point where we will learn how to configure the static NAT. We will going to configure the static NAT on ASA firewall. So our problem statement is that make the internal web server 10.0.0.10 accessible by any public host who is present anywhere on the internet using a public IP address 100.0.0.10. So you can see in this diagram, I have taken this public host as an example, which is sitting on a public IP address 128.0.0.1, and I want that this particular host should be able to access this web server, which is present somewhere inside XYZ Corporation intranet and is present on private IP address 10.0.0.10. But I want this public host to access this web server using public IP address 100.0.0.10, right? This public IP address is not assigned to any machine in reality. It is this public IP address that will be used in network address translation configuration. So you can see this is the configuration that we need to do on firewall. And you can see that this configuration is very simple, right? It involves just 3 steps. The first 2 steps are related. That is, in the first 2 steps, we are creating an object network web server whose IP address is 10.0.0.10. So remember, object networks are nothing but these are the collection of IP addresses. So here we are creating an object network called web server. And inside this object network, we are putting only one IP address, that is 10.0.0.10. Alright, so this is the way to give IP addresses some meaningful names, right? Throughout the configuration that I will do on this firewall, in any configuration, if I ever need to use an IP address 10.0.0.10, instead of specifying the IP address, I can specify human-friendly name, which is nothing but web server. Having said that, the third rule is the rule where I configure the static NAT. We configure the static NAT within the object network itself. So you can see this is the hierarchy of configuration, and we are configuring the network address translation within the object network web server. And the semantics or the meaning of this statement is that we are creating a network address translation rule which would be imposed on any packet which is hitting the firewall at the inside interface, and this is the static rule. And any packet which has a source IP address 10.0.0.10, this source IP address would be translated by 100.0.0.10. This is the semantic of this rule. And after the IP address, that is the source IP address of the packet, has changed, then push the packet out of the interface, which is referred to as outside. So this is the complete meaning of this line, network address translation. Now note that here understanding the syntax of the configuration is not important. What is important is that you understand the concept. Because if tomorrow you work on some other device, not ASA firewall, then there you can see completely different syntax to configure network address translation. But you should understand the meaning. The concept is same across all devices. The only difference you will find is in the syntax of the statement or configurations, right? So focus on the concept. So here I have written in simple English words that this particular network address translation configuration has 2 meanings. One is for translation and another is for untranslation. So let us go to the lab straight away, and I will show you how this static network address translation rule come into enforcement. What we will do, we will go to the lab which we have constructed, and you can see that all the nodes are up and running. Now on ASA firewall, I will going to configure network address translation rule. So here I am on the console of ASA firewall. Go to the configuration mode, create an object network, and let's call it web server. Give an IP address 10.0.0.10 And now configure network address translation rule. Inside, outside, note that there should be no space between inside and outside. They are separated by comma. Static, and specify that with what IP address this 10.0.0.10 should be replaced in the IP header of the packet. And we are done. So you can verify using show NAT command that your configuration has succeeded. And now I will go to public host H1, because eventually we want a public host to access the web server WS1, which is present inside XYZ Corporation. So from public host H1, are we able to ping WS1 web server using public IP address? Let's see. And you can see that we are able to ping. So we are able to ping because of this network address translation, right? Now let's say that I enable, why links are disappearing? Now you click on this link and do the packet capture. We will start the packet capture, and we want to capture the packet on the inside interface as well as outside interface of ASA firewall. So here I will start the packet capture. So I'm capturing the packets on both the links of ASA firewall, so that I can see the packet content after and before translation. So I will go to public host H1, and now I will do the ping again. And now I will see the packet content. So on this link, I will stop the capture. They don't show the capture. Let me download the capture file. And on the other link also, I will stop the capture and download the capture file. So guys, the Wireshark file that I have captured, I have placed them side by side. The file on the right hand side shows the capture on this link, whereas the file on the left hand side shows the capture on the left link of the firewall. So now let us analyze that when the packet was generated by public host H1, what was the source and destination IP address of ICMP echo request packet? So you can see the very first packet is the ICMP echo request packet, and the source address is 128.0.0.1, which is the source address of host H1, and the destination address is 100.0.0.10, that is the address which host H1 actually pinged, right? And when this packet crosses this ASA firewall boundary, then it will undergo untranslation, right? It will undergo untranslation. So you can see that the first packet on the left hand side is the packet which is formed after the ICMP echo request has undergone untranslation by crossing the Cisco ASA firewall boundary from outside interface to inside interface. So you can see that the destination IP address on the right hand side, it is 100.0.0.10. On the left hand side, it has changed to 10.0.0.10. So ICMP echo request finally reaches the web server 1, which has the destination IP address 10.0.0.10. Alright, so ICMP echo request has reached its intended destination, and the web server will generate ICMP echo reply. So the very next packet that you can see on the left hand side is the ICMP echo reply, which is generated by the web server. And obviously this packet will go back and hit the Cisco ASA firewall on interface gigabit 0 by 1. And now this packet will undergo translation. So the source IP address of ICMP reply packet would change from 10.0.0.10 on the left hand side, the second packet, to 100.0.0.10, the second packet on the right hand side, right? So this is ICMP echo reply, and eventually ICMP echo reply reaches the public host H1. Alright, so you can see that translation and untranslation is fully working. The packet first undergo untranslation and then it undergoes translation on its return journey. So that's the power of network address translation. The public host H1 is able to access the web server or a machine which is present in the private network of XYZ Corporation using public IP address. But in reality, it is communicating with the machine which is sitting on a private IP address. So that's it with the static NAT.